writing of the standards was one of the most exciting moments in my life, and I think it's an exciting moment in this nation's history. It was a remarkable coming together of lots of organizations, lots of states. We had a situation where different states had widely different standards. The curriculum in the United States has often been criticized for being a mile wide and an inch deep. And we had an opportunity to really write something aspirational, something that brought states together around a common understanding of what we wanted to get out of our education system and what we wanted for our children.
And when the states came together, the goal wasn't simply for them all to begin doing the same thing. The goal was for all of them to raise their game and do math education better. So our charge wasn't to combine or average or concatenate all the standards together or regress to the mean, but to build on what the best states were doing. In producing these standards, the working group was charged with using evidence to an unprecedented degree. Evidence about what high-performing countries do in mathematics, evidence about the true demands of college and careers. And when you look into that evidence, what you see at the far end is a problem of remediation. That students, even students who meet expectations in high school, go on to the next level and find that they're not really prepared. So there's a mismatch of expectations. And when you look into the data, you see that post-secondary instructors are looking for a deeper mastery of the fundamentals, a greater command of fewer things, a greater ability to apply those things, whereas many K-12 teachers feel they have to cover everything or their students won't be ready. So there's a conflict between coverage versus focus and coherence.
We had an opportunity to really give guidance to teachers about the mathematical underpinnings of what they were doing, how what they were doing all fit together. We tried to write standards that were coherent. So by coherent, we mean that those standards will be progressing from one grade to the next so that teachers will understand why they're teaching what they're teaching at their grade level, what they're preparing for in the next grade level, what they can expect students come in with when they come into their grade. Teachers are no longer isolated in time in that way, nor are they isolated geographically since they're sharing these common standards. The groups that came together were many. We had many individuals who had been prominent in thinking about mathematics education in this country: mathematicians, educators, teachers, policymakers, many organizations that had been involved. The Conference Board of Mathematical Sciences is an umbrella organization that encompasses 17 mathematics organizations, including the education organizations more oriented towards teaching, NCTM, NCSM, ASSM, and AMTE. Also, the organizations of mathematicians, the American Mathematical Society and the Mathematical Association of America. We had a work team of about 60 people that brought together all these constituencies. And they really worked in an amazing way. They cycled back with the central writing team, which consisted of myself, Jason Zimber, and Phil Darrow, supplied us with a lot of raw material that really helped us build this coherence. The other important principle that was that we adopted was the idea of focus.
Focus means spending more time on fewer things at any given grade, principally on number and operations in early grades. This is to give teachers more time to teach those things to mastery and give students a firm foundation on which to build. And the point is that math is not like a homogeneous fluid that can be ladled into bowls and served to students. It has a logical structure with lots of connections, some of them intricate. At every level, there are intricate, difficult, and necessary things that are prerequisites for the next level's intricate, difficult, and necessary things.
The other principle that we designed was the idea of progressing across grade levels. That is, we wanted teachers to be able to see how it all fit together, how the mathematics fit together, what was the mathematical implications of what they were doing, so that they knew where they were heading. A good example of this is the way the standards deal with number and operations in elementary school, growing into a really unified understanding in middle school of the number system. You know, when kids learn about fractions or about whole number arithmetic, they often think these are very different beasts. The way you add fractions certainly doesn't look like the way you add whole numbers. But in the end, they're just numbers, and at some point, kids need to get an understanding of how the number system works. So there's that real focus on number and operations in elementary school. We did not put into the standards a lot of the things that people have come to expect in state standards in elementary school, because we wanted to give students a chance to really build that basic foundation. So, for example, the elementary grades do not pay a huge amount of attention to data, to work with data, although there are standards that prepare for that. They don't pay a huge amount of attention to patterns, but there's a real focus on the way the number work prepares you for algebra, so that in middle school, students have this rich experience with statistics. That's where they start really learning about probability and statistics. They have good hands-on experience with geometry, so that geometry really comes to life for them. And of course, the important principle was to aim for a situation where around 8th or 9th grade, students could start having a serious engagement with algebra. There's a lot of algebra in the grade 8 standards, and we've really tried to design them so that there's a ramp up to that, starting even in kindergarten, with the focus on thinking about the way operations work. Another change, that's something that's a little bit different from the way normal standards are written, is often state standards have been broken up into what's called strands. There'll be 4 main strands that go all the way from kindergarten to 12th grade. Number and operations, algebra, geometry, data or statistics. We tried to do a slightly more fine-grained arrangement of the standards into what we call domains, which was another way of getting across this idea that you have to focus on something for a certain time, and then it comes to an end.
The Common Core standards are clear expectations, but they're challenging expectations for higher math performance. The content standards have high cognitive demand. They stress conceptual understanding, procedural skill and fluency, and problem solving. The mathematical practices are the varieties of expertise that we want to develop in students, and the standards ask us to connect content and skills. So the shift we're talking about is towards greater focus and coherence. With more focus, kids have more time to make sense of the mathematics and master it so that they can build on those foundations. A focused and coherent approach to math can help students master the math they need for college, work, and life. My mother-in-law is a 7th grade math teacher, and as you can imagine, we talk a lot about the Common Core state standards. And she tells me that she used to always have to decide what to leave out, and she never knew what she was sacrificing for her kids in making those decisions. And she loves the Common Core standards because they tell her that it's okay to focus on what matters.